questions again?
So I'll ask the questions,
Sure.
you'll answer the questions. So where are we right now and who are you?
Yeah, we're in Baysville, Ontario. My name's Kyle Little. I'm construction manager for Fourth Pig. So we do sustainable, natural, non-toxic construction, and recent years we've been putting a focus on passive house construction, and so high thermal efficiency, high energy efficiency, and low carbon.
Excellent. Can you tell us a little bit about the house we're standing in front of right now?
Yeah, so it's a 2 unit. It was constructed with the intention of being kind of a pilot project for us. It's the first spec build that we've done up here, and uh, there's a shortage of housing in Muskoka, which some people are aware of and some are not. So this particular property is just a 2 unit, but we've been in conversation with the township and municipality about the next 2 lots over, which Tree also owns, talking about doing 4-plex, maybe 6-plex, maybe even 10-plex if we can figure out how to get the density onto the site. So,
And who's Tree?
Tree is kind of a sister company and business alliance between Fourth Pig. So Melinda Zeterik is one of the founding members of Fourth Pig, and she's also a worker owner and general manager. And her father is Rick Zeterik, and so together they started Tree Passive Homes, which builds carbon sequestering, natural, high thermal efficiency prefabricated building components.
And this house here is implementing walls and floor system from Tuke?
Correct, yeah. Tree supplied and assisted with installation for entirely prefabricated floor and walls, and then it's a conventional flat bottom engineered truss roof system with loose blown cellulose.
Awesome. Okay, let's have a small chat or a short chat about the foundation of this particular building.
Sure, yeah. So one of the things that we focus on is reducing concrete usage or consumption, because concrete contributes to, I believe, somewhere close to 40% of all of the carbon emissions that the construction industry is responsible for. So the less of that we can use, and the more responsibly we can use it, the better it is for the environment. So here, rather than doing like a conventional concrete basement or even a frost wall or a slab on grade, we opted to do these helical piles. Keep going.
Okay, so you used helical piles for this foundation?
Yes, the foundation is all helical piles, no concrete. So they were basically installed based on friction resistance. So they're driven in based on a specific friction rating that they need to hit, and the piece of equipment basically registers that as they're being screwed into the ground, and when they reach the correct resistance, they stop. So we've got adequate engineered bearing capacity here without the use of any concrete, which is great.
Talk to me about the gravel base that we see here.
Yeah, so the gravel is here, one for kind of improved drainage under the building. You'll also see a bit of 10 mil poly that's exposed here, which we've used as a ground vapor barrier. It's not really a code requirement in this application, but we thought it was just best practice to minimize any potential water or moisture kind of getting trapped underneath the building and contributing to rot or damage.
And the big box that we see right behind you there? What's in there?
So that is one of our service cavities for the site services that need to come into the building or exit the building. The lot is on municipal water and sewer, and then we've got hydro at the road. So we've got a electrical service and sewer and water supply pipes inside of this conduit and two other entrance points to this 2-unit building. The conduit is insulated, and then there's also a heat trace line on the supply water inside the conduit, just to protect from any potential freeze damage.
Okay, great. Thanks.
Yep.
So, air source heat pump for the central heating for the house. A unit that size for a 1,500 square foot conventionally built and insulated home wouldn't have a chance of keeping up. It would barely heat one room.
Yeah.
So what are we looking at for the R value in our walls and floors and ceiling system in this house?
Yeah, so the floor and walls here are approximately R50, and the attic is between R80 and R90. I think it's around an R85 probably.
So a typical home build, we're looking at about R22 to an R24 in the walls. So you've doubled the walls.
Yeah.
Most of the time we have a foundation. So foundation insulation, we're looking at around R12 to R22. And in the attics, we're at R50. So you're basically doubling and tripling in every area. Yeah. And of course, seal, right?
Yeah, so the whole building has to be, it's equally, if not more important, to air seal the envelope as it is to insulate it. If you have insulated it well, but it's not air sealed, then the insulation doesn't really matter so much, because all of your heat transference is just gonna leak out through all the gaps. So it also would cause water and moisture problems and premature damage and rot to the building.
I see a shower tub surround here. The people that'll occupy this house are going to want hot water.
Yeah.
How do you supply hot water?
Yeah, so again, it's going to be using air source heat pump technology. So the hot water tank is what's called an air source heat pump hybrid electric hot water tank. During the spring, summer, fall, it could be run basically just off of the air source heat pump. During the winter, it would probably get switched over to electric, because when you're running the air source heat pump to create hot water, the byproduct of the heat pump is actually cold or cool air. Which you don't want to introduce necessarily into your conditioned living space during the winter time when you're also heating it. Otherwise, you're being a bit counterproductive. So
now, outside of the cost of doing something like a geothermal, where it's a heat pump but using ground heat rather than air, do you incorporate geothermal into many of your builds at all?
We don't. I personally have done 3 projects that had geothermal. 2 of them were with more of a linear ground loop, and one of them, because it was in a dense downtown lot, we went with 3 loops that were vertical, and each loop was about 450 feet deep. Typically what we've found, though, even though technology is getting better and more affordable, is that geothermal usually is not cost competitive with the other heating and cooling options, unless it's for either a very large single family residence, which in my mind would be 10,000 plus feet, square feet, or if it's multi-unit or like a development or a subdivision that could kind of utilize that infrastructure to service multiple buildings, then it becomes much more a cost-effective option.
Yeah, another builder that I've worked with are big on geothermal. They build huge homes in that, and I can't wrap my head around geothermal for Ontario. Especially when we're augmenting with either propane or electric after the fact. And these are a conventionally built home, right? So we don't have the R values that would support kind of the meager returns that you get from air source or thermal source heat pumps, right? It's kind of throwing in a geothermal into a regular house and saying I'm green is kind of silly. It needs to be thought of through the entire design process, but this is all good. So air source heat pump for central heating as well as your hot water, and then of course we have no foundation, so all of the ductwork is up in the attic space. So lots of time and energy, I'm sure, spent insulating ductwork.
Yeah, it's actually in either service cavities or bulkheads, which are dropped. So it's all inside of our conditioned envelope. It's not up in the attic, which is nice. The ductwork itself here, it's not as elaborate as a conventional HVAC system would be. In most cases, the runs that are coming off this, with the exception of primary runs, which I believe are 8-inch diameter, and they bring in the fresh air and take out the stale air, the rest of the branches are 5 or 6-inch round duct. So it's fairly easy to accommodate those runs to the bedrooms and washrooms and kitchen and living room just by putting in a drop bulkhead to bring the ceiling. So most of the ceilings in here were constructed at 9 feet, so that we allowed ourselves essentially a foot of headroom to drop for bulkheads, which brings it down to 8 feet. So all of the spaces still feel really comfortable, and the HVAC has been accommodated.
All right, excellent. Thank you. Okay, we're inside now. Tell me a little bit about the interior finishes, your wall finish for this particular project.
Yeah, so this is basically conventional drywall that we've done. It's just mudded, sanded, primed, and painted. Cheap and cheerful. We often have natural plasters on our jobs, but on this particular one, we were trying to basically keep the costs down and keep the building as kind of affordable, whether it's going to be a rental or a sale, as possible. And plaster has a tendency of being a bit labor intensive. We also we've got some talented people within the company that do plaster, but we don't necessarily have easy access to the plastering crews that you would find down in Kitchener-Waterloo or GTA or Ottawa, unless we pay them to come up here, which can be cost prohibitive. So, yeah.
Okay, so standard drywall interior. Tell us about these windows.
Yeah, so these are fiberglass triple glazed windows from Inline, which is a Canadian company. They're just very, again, kind of cost-effective, high thermal performance, and nice aesthetic. They do a good window. The doors, sliders, and entrance doors here are also from Inline. So they're all fiberglass, which is, we try to use either fiberglass or solid wood for windows and doors. We don't use vinyl for environmental reasons.
And the floor finish right behind me here, we've got a wide plank oak. What is unique about that?
So this is from Nadura in Toronto. It is no added urea formaldehyde and FSC certified. We like getting our woods from there. Probably, I'm guessing 95% of our projects we source our flooring from there, just because we know that they've already curated the selection for us, so we don't need to ask if it's FSC or NAUF. We just know that it is, which is great.
And is it going to be a glue down or a nail down?
It'll be a nail down, partially because the adhesives that are on the market have a tendency to be kind of toxic and nasty as well. So again, we try to minimize the use of anything that has unpleasant VOCs that would potentially not be great for our crew while they're installing it, or for the eventual occupant of the building.
And the kitchen is sourced from where?
Kitchen's actually going to be IKEA for similar reasons in terms of it being an economical and fairly resilient option. And they also have a pretty good kind of combination of following either European or California standards in terms of the allowable off-gassing and composition of the materials. So it's not a bad option, especially if you're looking for an economical source.
Excellent. Millwork, doors and such is all going to be...
It'll all be solid pine, FSC again. And then, yeah, this is our mechanical closet inside of the large unit washroom. So this is one of the places where the building really kind of sets itself apart from most other buildings and projects that are kind of underway in North America. We don't have a conventional furnace here. We have this Minutair unit from Quebec, which is an air source heat pump. It does the fresh air supply and exhaust ventilation for the whole 3-bedroom. There's another unit in the 2-bedroom at the back. And it also uses the air source heat pump to provide heating in the winter and cooling in the summer. And it's been incorporated into the mechanical modeling for the building. So yeah, it should be able to provide hopefully 95% of the heating and cooling. And then we have, eventually, they're not installed yet, but we will have some backup electric baseboard heaters that would provide the backup heat if necessary. If it's, say, minus 40 for 10 days in a row, maybe they're going to kick on after a few days.
Excellent. All right, class. Well, that was our site visit with the Fourth Pig. Pretty unique home. No conventional foundation, so all on helical piles, so that ties in with what we're doing. The exterior finishes of the house we didn't get into with Kyle. It's going to be an enamel-coated corrugated steel for the walls, and it has a steel roof, corrugated steel roof for the roof finish. So they chose that because of economics, durability, and longevity, right? So it's interesting to see the combination of materials being used, which is going to give us our longest life, and what's going to not be cost prohibitive. So a pretty cool job site. Outside of outside of no foundation, I don't think you'd walk up to this project and think it was unique at all until you got to the window wells and you saw how wide the jam extensions have to be to incorporate those walls. So big thanks to the Fourth Pig for having us out here for a site visit. And yeah, if you guys have any questions for me, shoot them off and I will be happy to answer them. Cheers.